Good morning, friends and neighbors. I'm afraid my voice is rather harsh today, but I'm not here to sing opera, so I think we'll get by. Now, people throughout the world have certainly noticed from earliest times that many different animals come to flowers, apparently quite eagerly. And many people must have taken the further step of learning that flowers often have sweet nectar in the depths of their corollas, which would account for the animals coming to the flowers. However, understanding of the deeper relationship between flowers and the animals that visit them is by no means obvious. It's far from obvious. The first key step in understanding this did not come until 1793. The step was taken in this book by Christian Konrad Sprengel, titled The Revealed Secret of Nature in the Structure and Fertilization of Flowers. In this book, he laid the groundwork for today's flourishing discipline of pollination biology. In short, Sprengel explained what flowers are for, what they're all about, their place in the reproduction of their plants, and the reproduction of flowering plants, which make up the bulk of species of plants in our world today. In addition, Sprengel showed that features of particular flowers, such as size, shape, color, even their smell, are closely associated with their main pollinator or pollinators. So that, excuse me, if a knowledgeable person goes out into the field and encounters a plant, a flower that she has never seen before, by examining these features, that knowledgeable person can conjecture with reasonable confidence what the main pollinator or pollinators are. Now, my topic today is one particular class of frequent flower visitors. The Hymenoptera are one of several major orders of insects. Most of the Hymenoptera we know as wasps in common speech, and these are certainly something with which you are familiar. Most wasps capture insects or other prey, which they feed to their larvae, to grow as the nourishment for the larvae. So this one, for instance, is going to capture caterpillars, and she will put them in her nest, and the larvae will feed from them. This other one, a mud dauber, has captured a spider, as you can see, and she's specialized to provision with nothing but spiders. There is, however, one peculiar group of wasps, numbering an estimated 20,000 species throughout the world, that has made an evolutionary switch from provisioning with prey to pollen as the protein source for the larvae. And to this they add nectar. These wasps are so distinctive that in common speech we have a special name for them. We call them bees. Accordingly, you can define bees very simply as that lineage of wasps that has made the radical switch in provisioning its growing larvae with the products of flowers, to the provisioning with pollen and nectar. And all of the special features excuse me, of bees can be related to this one radical shift in their habit. let's take a look at some bees. So here is a bee, a solitary bee. Here are bumblebees. We don't have any bumblebees in the West Indies. What people often call bumblebees are in fact carpenter bees, which superficially are rather similar. Here is a colony of stingless bees at its entrance tube. And here is your beloved honeybee. As you can see, she is visiting flowers. So you've seen plenty of bees throughout your existence. And if I were to ask you, even before you've looked at these pictures, what it is that sets bees apart from the wasps that we know as wasps, what many of you would say is that bees, unlike wasps, are fuzzy. And that's, you're right about that. And this is, so here, this is an important key to what bees are all about. Now here, we see a fire ant. And you see she's got hairs all over her body. If she were there at regular size, she wouldn't appear to be hairy, fuzzy at all. She just appeared to be quite sleek. And what you'll notice is that the hairs all over her body are sparse and they are simple. In contrast, look at this bumblebee. And as we've noticed in some of the earlier pictures, she's got a dense covering of hair over her body, as do most bees. Now, the hairs are not only very abundant, but unlike the simple hairs of most insects, they are branched. So here you see some typical bee hairs, and you notice that they're not simple. They've got branches going out. The result of this is that when a bee gets inside and intimate with a flower, she gets dusted by that flower's pollen. She gets it all over her body. So here we see a honeybee that has been up close and intimate with a flower, and she's got plenty of pollen all over her body. Most pollen is yellow. So most animals, including insects, make an effort to keep the body clean. They remove any kind of dust or grime with stereotyped grooming motions. Now bees, instead of using their grooming motions just to get rid of the pollen and discard it, which is what they do with ordinary dust, have ways of using the cleaning motions to pack that pollen into specialized carrying devices. So you see the bee on the left here has hind legs that have these brushes over the tibiae to collect pollen. The one on the right has a dense brush of hairs on the underside of the abdomen, which can also be used for carrying pollen. Honeybees and their relatives have a specialized pollen-carrying device on the hind legs, which is known as a pollen basket or corbicula. So you saw the honeybee a moment ago, who had pollen dusted all over her. This bee has managed to concentrate that pollen that was all over her body into these devices. So very often, excuse me, you will see bees visiting flowers or out in the wild that have to be what look like yellow saddlebags on their hind legs. And these are quantities of pollen packed into their pollen baskets. Many bees have now, if bees were perfectly efficient in collecting their pollen and taking it back to the nest, then it wouldn't do the plants any good. But in fact, they're far from efficient. They're actually rather sloppy. And so that when a bee goes from one flower and gets pollen dusted over the body and most of it collected into her pollen-carrying devices, and she visits another flower, then some of that will be dislodged onto the flower and will result in pollination. Now, the result of this, all of this, is that from these visits to flowers, the bee benefits by gaining brood food, while the plant benefits from pollination. Now, that sounds like a partnership, doesn't it? And even if neither partner is at all aware of what's going on. And as in most partnerships, there is an overlap of interests between the partners, but there is not a perfect overlap. Their interests are not identical. So the plant produces nectar at a metabolic cost, so that the plant would benefit if it could produce and deliver just the minimum amount of nectar to attract bees who would come and effect pollination. The bee, on the other hand, undergoes an energetic cost in flying out and collecting pollen. So if the bee were to encounter within her foraging range 2 patches of flowers, one of which delivered a better reward and one of which delivered less reward, then you would expect her to concentrate on the better patch of flowers and neglect the other. So that you can see that the plant cannot cut back on the reward too much, because if it does, it will damage the partnership. Now, through various agencies, pollination is affected through various agencies. But most flowering plants, are pollinated by animals, of which bees form the predominant group. As you may have heard or read in the news, populations of insects, excuse me, in some parts of the world are now demonstrated to be in serious decline. And among these are various species of bees. Now, does this have anything to do with you in your daily life? And I expect some of you already see exactly where this is going. After all, even if you are not a vegetarian, you eat a lot of vegetables and fruits, or at least I certainly hope you do. And so the question arises, what difference would it make to you if populations of honeybees, stingless bees, and the various solitary bees were all to disappear from the fields and orchards of Trinidad, or at least were to become very sparse? Now, to illustrate this, about a month ago, I took a walk, excuse me, through the Tunapuna market, and I made a note of all of the fruits and vegetables that were available there. Now, I hope you can all read this, but I don't know what your screen looks like, so I'm going to read just the first few, just to give you an idea. Apple, avocado or zaboka, banana, beetroot, bitter gourd or koraili, black bean, black-eyed pea, bodhi, breadfruit, broccoli, cabbage, carrot, cassava, cauliflower, celery, chili pepper, and so forth. And as you can see, right there in the Tunapuna market, we've got a pretty good variety, almost 60 things on this one ordinary day were available for us. Now, you can infer from this commonplace example that bees are probably important. But we're going to go on. We're going to belabor that point. Now, note when you, if you can read this, okay, you will note that in some cases, a particular species, the scientific names are in italics to the right of each common name. In some cases, a particular species of plant has been bred to form 2 or more distinctive products. So you see, for instance, that banana or fig is the same species as plantain, but they've been bred to be different, and we use them differently. So I've treated them as different products in the market. Similarly, you may notice that the same scientific name comes up for cauliflower, cabbage, and broccoli. So these are all the same species, but they've been bred to be different, so that we treat them as different. We cook them differently. Now, let's look at the same list. And in this list, what I have done is I have de-emphasized by making the font smaller. I've de-emphasized those fruits and vegetables that are not, in which bees are not important pollinators, in which bee pollination is not very important, may not be used at all in the production of them. And just take a moment to look at that, look over that list. And I think what you will see right away, even just at a glance, is that most of those are in large font. So we go down, apple and avocado are in large font, require bees for most of their propagation. Banana or fig does not, so it's in small font. Beetroot, bitter gourd, black bean, black-eyed peas, etc. are in large font. And then we come down, and we have to come all the way down to dasheen and edos to find something that is in small font. What this tells you right away is that right here in Trinidad, we rely upon bees to pollinate most of the fruits and vegetables that we eat on a daily basis. And you can infer from this that if bees were to become very scarce in our environment, you would be eating an awful lot of green fig, dasheen, edos, and yams, among others, and that it would cost a lot more. So the key message from all of this, okay, folks, pardon me, but the neighbor's yard birds came in and they got no behavior. Okay, to come back to Albert Einstein, what he's saying is that if the bees were to disappear, not only would our diet be much restricted, but it would probably be the death of humanity. He says within 4 years. That may be an exaggeration, but to put it another way, if you're going to badmouth beekeepers and their bees, don't do it with your mouth full.